Hi guys, so today I'm going to review a number of Rhino commands that you can use to orient different geometries along a surface. So today I'm just starting out with a couple different flat surfaces with some objects on them. We've got a sphere, a circle, a pole, and then I also have some surfaces that are curved that I just simply made by turning on the points of a flat surface and then pulling them up or down. If you want to continue editing a surface such as this, another easy way to edit a surface is the CageEdit command. So we'll type in CageEdit after clicking on the surface. And it'll ask for a control object, and we just want to create a bounding box. So we'll click here, bounding box. And you can just go through the rest of these, whatever, just press enter. They're less important. So I can select different points, and then I can, pull them up, off to the side, so on and so forth, and then I have edited my surface. So that's another easy way to do that, but we don't want to actually do that today. Okay. So the first thing we're going to do is we're going to go over how to take line work that we have and put that on a surface that is not flat. So first thing I want to do is I want to actually spread this line work out across this flat surface that I have. So this is similar to the tessellations that you guys made. So the way I'm going to do that is using the array command. So type in array. It's going to ask for the number that you want in the x direction, so I'm going to choose 16. And then the y direction, I'll choose 8. I already have this set up, but you could type in whatever you wanted. It's also going to ask for the z direction, so you can make arrays in a three-dimensional space. You can pull them up if you want to and have these stacked array type of situation. But for the sake of this tutorial, we're not going to do that, so we're just going to leave that at 1, so we get a flat array. And then it asks for the unit cell or the spacing. I'm just going to go in here and roughly click at the center of my circle, and then we're going to stretch this out across our surface. Whoa. Try that again, sorry. Okay, so that's good enough for me. Great. Now, how do we get this array of curves onto a curved surface like this? So there's two commands I'm going to show you guys. They operate in a similar way, but are a little bit different in terms of their mathematical functions. So first thing I'm going to do is I'm going to take this array of circles, and I'm going to lift it up off here using the gumball, and then I'm just going to pull it over to be over top of the surface that I actually want the curves to be on. So that's pretty good. So the two commands we're going to use are project and pull. So first I'll just do project. Let's type in project. And this does pretty much what you think it does. It projects the curves or the circles down onto the surface. There's also an option here to either delete input or not. And what that will do is it will either delete these curves up here that are flat, or it will keep them, and you can have both. But for the sake of clarity, I am going to delete the input. So you'll see that these are going to disappear, and these new ones are going to show up. But if you wanted to keep both, then you would not delete your input. So it's asking for the surface that I want to project onto, and I'm going to click this surface and press enter, and voila! We now have all our curves along this curved surface. So great, pretty easy, right? The similar command to that is called pull, and as you can see, project neatly placed our geometry down onto the surface without any real distortion. But what pull does is it actually fits the curves onto the surface while taking note of the slope or the steepness of the curve, and so it will actually lead to distortion of your geometry that's directly correlated with how steep the surface is. So I'll show you guys that. So this is pull instead of project. Let's select this surface here, press enter. Whoa, okay, so we got some really weird stuff. You can see that from the top view here. So yeah, so you can see like this was a high spot here, and then this is a spot that has a pretty steep curve here, and so when the circle came down, it hit that slope and was stretched down across the slope. Some of these are stretched down so far actually that they cross over themselves, and so you get some weird irrational geometry that's actually unusable. So that's not desirable, and that's kind of the thing to watch out for with pull, is that it can distort things so far much farther than you kind of want it to. But it also is really interesting if we're looking at top view. I mean, we can really start to visualize the slope of this surface just by kind of looking at what's going on here. You can tell that this is sort of a flat place, and that this was stretched down into this low place, and there's a little high place here. This is a high place that stretches down. So you can really kind of see what's going on just because of the distortions we've made. So it's interesting. It's definitely worth playing around with. You might be able to get some cool effects. But if I actually go, I'm gonna just show you guys. So if I just go and project this one more time, you can, once you have your curves onto your surface, you don't have to stop there. So I can take these and I can extrude them up, let's say, and I get these sort of cylinders, right? So now I have all these cylinders whose tops are actually the exact correlated with my surface, right? So that's kind of cool. And yeah, there's all sorts of other stuff you guys could do. So you just have to play around with it. But just getting these on the surface is just the first step. There's a lot of things you can do after that. So yeah, so I'm just gonna back up real quick, place that there. Okay, so we've done our line work, but what if we have a 3D object, like a sphere or something, that we want to array along a curved surface? So I have this sphere here. You can see that's actually, from this view, you can see it's actually embedded down into this surface. So the first thing we're going to do is exactly what we did with the circles, is we're going to make an array of these across our surface. We'll do the same x, y direction, 16, 8, 1 for the z. Just press or click in the center here. We're going to stretch these guys out across our surface, like so. Great. Okay. And then we'll select them. So you can't use project or pull with three-dimensional geometries. They require their own command. And that command is FlowAlongSrf. I typed in that, so it's asking me for my base, to select a corner of my base surface. So I'm just going to go down here. I'm not going to click on the edge or even the corner, but just kind of like near the corner, like that. And then it's asking for the matching corner on our target surface, which would be this corner here on our target surface. So if we click here, it's going to do some math. And bam! Okay, so now we have our array of spheres, except they are oriented along our surface here. So there's an option within this command, FlowAlongSrf, that is similar to the difference between pull and project. And you can't really see that much with the spheres, so I'm actually, in order to demonstrate this, I'm going to go over to this pull that I have, and I'm going to make an array of these. Super quick, so you guys can see this. Okay. Great. Okay. So I have this array of poles, and I'm going to show you guys the difference between this setting. And one is going to distort our geometry in the same way that pole distorted our geometry, and the other is going to keep it. So if we do flow along surface again, that option is this rigid option. So if we choose rigid yes, then there will be no distortion of our 3D geometry whatsoever. It will stay the same. It will just be tilted to be perpendicular to wherever it's placed on the surface. But if we check that off and rigid is set to no, then the geometry will actually be distorted based off of the slope of the surface wherever that individual piece of geometry landed. So I'll show you the difference between the two of these. So we have rigid off right now. It says no. We'll go in and we'll select our base surface. Excuse me. Here we go. And then we'll go over here, select the same, and boom. Okay, so if we go in here and zoom in, we can especially see with this guy, right? So this was on this, so the top of this hill or whatever. And so it's really distorted. It has, tired. Oh, it's that time of the year, guys. Anyway, so it has a much wider top, and then some of these you'll see have more narrow tops, and this all just depends on whether this lands on a concave or a convex part of the surface. So there's some small distortion there, and that can lead to some cool effects depending on the 3D geometry that you're using. This just looks, kind of horrendous actually. Maybe cool, I don't know. Pretty metal. But I'll show you guys how to do this so that you don't get any distortion. So we do flow along surface again, but we choose yes for the rigid option. Come on, there we go. And we're gonna click the base surface, boom, and then this guy. Okay, so now when I go in here, you can see that the poles themselves are not distorted. They're just simply tilted based off of the slope of wherever they landed on the surface. So yeah, so that's sort of the 3D version of project and of pole. And I actually forgot to mention, you can use FlowAlongSrf for curves and line work as well. And it, now that I think about it, it might even be more precise to do it that way. So if we do flow along surface, and we hit our base corner here, bam. So you can see we got a very similar effect from what we did with project. So you can also use flow along surface with line work. It's a really great command. So something to just notice about the surfaces we're working on right now. These are all the same size, or they all have the same proportion. They're all the same outside dimensions. They have the same perimeter, and that's really important to the way these commands work. And that's why we choose one corner and then correspond it with the other corner, is so that we can take each individual piece of geometry and we can place it in the exact corresponding spot on that other surface. You don't have to have two surfaces that match, but if you don't, then there will be some sort of distortion that happens. It will either distort your array, it will stretch out your array, or it will stretch out the individual geometry of whatever you're orienting along the surface. And I'll show you that here really quick. So let's take our spheres. Okay, let's take our spheres and let's do flow along surface. But we'll actually go down here to the end and we'll use this big surface. So this surface is just like a stretched out version of this guy. these smaller ones. And we'll have rigid to yes, so our individual spheres won't be distorted in any way. We'll click on base, and then the corresponding guy over here. And then, okay, so we can see now that our spheres have remained the same. They're the same size. They look the same, but our array has been spaced out. Our array has been stretched out to fit the dimensions of this much larger surface. So you can do that, and that will work perfectly fine. Just know that your spacing will change. The other thing that you can do is we can turn rigid off. So flow along surface, we'll turn rigid off, and we'll do the same thing. We'll do some math. Okay, so we turned rigid off. We allowed our geometries to become distorted, and what it did is it stretched our spheres out horizontally, which is exactly what we did to the surface. And so the spheres now match that. And so instead of spheres, we sort of have these little like pads, which is actually pretty cool. It's kind of a cool effect. So distortion can be your friend if you let it be, but you just have to be careful about the geometries that you get, because Rhino can make impossible geometries because it's just all on the computer. So just be cognizant of the way you're distorting things and be intentional. But you can get some cool things through those distortions. So another thing that some people asked was about when they were doing flow along surface. It seemed like it was like coming in upside down and weird stuff like that. So I'm going to show you kind of how to correct that. So I'm going to use these poles actually. So let's say I'm going in, I'm excited, I'm going to do a flow along surface, it's going to be great, it's going to be amazing. Come in here, click my base, find my nice surface, click on that. What? Why is it upside down? Ugh. Okay, so I can tell you why it's upside down. This is upside down, and it also looks like, if we look at it, it also looks like the array got messed up. It's not the same array that we had before. So there's two things going on here. This all has to do with the directionality of the way this surface is built. But we can fix that. So let's just undo. Let's click on our surface. And we're going to type in dir, which is short for direction. So there's two things we need to change. First, our things came in upside down, so we have to flip the orientation of the surface. So we're going to go up here and flip, and you'll see these arrows flip down. So we've got that, and then we also noticed that our array looked like it was flipped. So instead of 16 by 8, we had like 8 by 16, and so that has to do with the U and the V orientations of your surface. So we're actually going to swap U and V as well. So now that we've done both of those things, we'll press enter. Okay, so now this surface, which was built opposite of the surface that, the base surface that we were using, it will now match. And so hopefully we'll get a better result. Let's see what we get. So we're going to do flow along surface. And we'll do rigid. Come in here, our base, go back over here, this guy, let's see what we get. Great, okay, so it's no longer upside down, the array looks correct, we have fixed everything. So yeah, if your flow along surface is not coming out the way you think it should be, it probably has something to do with the directionality of the way your surface is built. So just dir, and then just kind of play around with it until you get the desired result. Another thing we can do is we can, instead of projecting line work onto a surface, we can actually draw along a surface. So that command is interpolate curve on surface. So if you just type in that, you'll get it right here. Interpolate curve on surface. We're going to select the surface that we draw on. This guy, we'll do it here. And then we can just kind of go at it. We can draw a little happy hiking trail down through the mountain. Oh, we'll come back up the hill. Yeah, we'll have a nice view. There's a picnic. We're going to go down here, down to the river, blah, blah, blah. Boom. Okay, so now we have this great hiking trail that is following along our surface. The next cool thing we can do is, instead of arraying this in this grid-like fashion, we can also array things along curves. So we'll click on one sphere and we'll do ArrayCrv instead of ArrayCrv. And we'll select the path curve, which let's do a hiking trail. Okay, some options are going to come up. We can select either the number of items, which will place one at the start and one at the end, and then all these ones in between, or we can do the distance between items if you wanted to do that instead. I'll just do the number of items, so we'll do 20. Click OK. Oh, so this is important. So the one thing that I didn't do that it's easy to forget to do because it doesn't actually prompt you to do is you have to select the base point of the geometry so that it knows where on your 3D geometry that it should line up with the curve on. So let's do this again, and I'll show you that. So let's do ArrayCrv. Now let's click up here on base point so we can set that. That's important. So I'll come down here and set the base point for, oh, did that go away? Okay. Set the base point for my curve to the midpoint here. Okay, so now that is where this is going to place, that is where the geometry will be placed along the curve. So now if we go back and select the curve, we'll do 20, hit OK. There. Okay, so now you can see that we have placed these at the bottom up from that point along this curve, and it looks great. Doesn't it look great? I think it looks great. Okay, and then the last thing that we had a question on today was about connecting surfaces. And so you can do that with the MatchSrf command. So we'll type in MatchSrf like that. And then you just select the two edges of the surfaces you want to combine. So we'll do this guy, and then we'll do this guy. Okay, so you see how these arrows are going this way? So that's actually not what we want. We of course want the arrows going back the other way. So the way that we fix that is with this direction command. So we go up to here and we click on direction, and we just make sure that this is set to backward. That way it's going backward towards the surface we actually want to connect to. Whew. Oh, more yawns. Okay, so we've got backward. Let's press enter. Okay, so now we can see that we have connected these surfaces, and there's a couple different mathematical ways in which this interpolation occurs, and so you can play with these to kind of get whatever looks, sort of the most natural for me. It seems like this one looks to be the most natural for me. So I'm going to go ahead and click on that, hit OK. Okay, great. So now we have combined these surfaces. So yeah, I think that's everything in terms of orienting different objects along surfaces, and we'll put up another video for the Rhino to Illustrator workflow. But yeah, that is it for right now. Thanks, guys.